Hello, welcome to Miss Amy's vlog. So let's get back to the problem we had in class. Like we tried to write the algorithm for binary to ASCII converter, right? Using structured English. Okay, so when you try to solve a problem, you should think of the input and output, what is expected for us, right? So the input here should be a binary string, and the expected output should be the equivalent ASCII characters. Uh, so you first need to think of the solution as a human, right? A human using paper and pen to solve it. So if we were in chapter 1, and I give you a question like, convert this binary string into the equivalent ASCII code, ASCII characters, right? So how to solve it? So the first step will be read the binary string to be converted. Yes, we can read it, right? And then the next step would be open an ASCII table for reference. Okay, so you can open the textbook and find the ASCII table, or you can go to the internet and search for an ASCII table. I have had prepared a part of the ASCII code here. And as you can see, the ASCII code table has two columns. One column for the characters, the ASCII characters, and one for the binary numbers, binary codes. Okay, so the next step would be divide the string into groups of 8 bits. So how to do this? As a human, you can start counting, right? From the left to the right. So 1, 2, 3, 4, 5, 6, 7, 8. And then you can mark a line or, okay, so as I do here, I split them using the space. Okay, so we continue counting from 1. 1, 2, 3, 4, 5, 6, 7, 8. And split. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. I stop this because I know that there's no more character, no more like binary digit to count. So finish the third step here. And the next step would be start from the leftmost 8-bit code, look for it in the binary value column of the ASCII table, right? So I start from the leftmost group, this group, and look for it in the ASCII table. Of course, I have to look for the match in the binary code column, right? And it's here. Okay, it's here. After we finish searching for the match, if we find the match, the next step would be get the equivalent character in the character column. Okay, so I look for the character value on the same row. It is B, right? I get that value. And the next step would be write the character on paper. Okay, because we are human, we have paper and pen, or okay, like I'm illustrating here, I type letter B. What is the next step? So the next step would be we move on to the next group of 8 bits, right? And you can easily figure out that we do the same 3-step we did before. Continue with the next 8-bit code, look for it in the binary value column of the ASCII table. And then if you find a match in the table, get the equivalent character in the character column. Write the character on paper, right? So I bring this and search for it. Search for it. And here it is. I got the value D and write it down here. What next? Okay, things like seem repeated because we have one more group of 8 bits, right? So I repeat the same steps until the last group of 8-bit code is converted. Okay, so I look for this and find out this A and write A, and as a human I easily figure out that there's no more group of 8-bit codes for to search for. So I finish my process here and I read aloud the answer. So my solution is BDA, right? Okay, so that is how human can solve this problem. But it's not easy for the computer to understand the step. We need to adjust it to make it like readable by the computer. Uh, no, not yet. We need to make it like understandable and more computational, right? So we need to adjust it a little bit. Remember the like last last week we learned about distraction. No, sorry, decomposition. There's a technique that we call pattern recognition. As a human, after doing like all of this stuff, you can figure out that there's a pattern here, right? And the pattern includes 3 steps. Okay, so the 3 step, this and this 3 step, and the next 3 step are repeated, and we recognize the pattern. Okay, so to make it easier for the computer, we need to think as a computer, and we make it short by using the iteration structure, right? We have the loop, the repeat like keywords. Okay, so to adjust this into computational thinking and make it like the algorithm using structured English, I first copy this and try to adjust it a little bit. So the first step, it looks fine. Read the binary string to be converted, or you can convert this into input or enter the binary string or ask for the binary string to be converted, right? The second step, can the computer do this? Can it open a textbook? No, right? So we need to adjust this. As a programmer, you should you should prepare an ASCII table for the computer by initialize and set like okay, so things get complicated because computer like the computer is not familiar with table but another concept which is array, right? So with the computer you should think about data, how you use the data, how you manipulate the data. It's not like human because humans can use paper and pens, and you can easily write down the text anywhere on the paper. But for the computer, it's a more complicated process where the computer need to like take a part in the computer memory to store things. So you should think about the data as a variables, constants, and arrays, right? The data structure. So to help the computer have an ASCII table, I will use 2D arrays, because with 2D arrays I can easily create a table. So insert a table. Okay, so if you have paper and pen, yes, and you try to write the algorithm, you can draft a table down like this. Okay, so there's the ASCII table. Yes, in an array, right? An array of type string. So we initialize and set an array to the array for the ASCII table. Okay. So we already have the input. You may store the binary string inputted in a string variable. We may use an array for the ASCII table for reference. So how about the output? To store the output value, we should initialize a string variable. Why string variable? Actually, you can use an array, an 1D array for it, right? An array of type string. But I think it's more convenient to use string variable to store the output ASCII characters. Okay, so initialize a string variable for the output ASCII string. So we're done with the setup. Okay, so assume that this is the output string. Assume this is the output string. It's like a placeholder in the memory, right? Okay. The next step, divide the string into groups of 8 bits. Actually, the computer can implement this. Like how like we can use the substring routine, or you can like you can walk through the string, and then you can store each 8 bit in as an element of an 1D array, but this it can be it is not difficult to implement using the computer, so we can keep this. And the next step will be start from the left. Okay, so you see the pattern here, right? Instead of writing all of this down, we will try to convert try to access it using the repeat structure. Repeat for each group of 8-bit code. Repeat what? Repeat, look for it in the binary value column of the ASCII table. I forgot to set the table, right? So to set the table, we should start like you can assign the value to you can initialize the value to each rows of the table. So the first row for the binary code 1 and so on, and the second row for character and so on. Okay, assume that we have the complete ASCII table now. So get back to this. Look for the 8 bits in the column in the binary value column. Oh no, we set up this as a 2-row, so look for the binary value row, the first row, right? And then if you find the match, get the equivalent character in the character column and write the character on paper. Actually, there's no paper and pen here to write, so you can change this a little bit by append the equivalent character in the character column. No, it's come row now. In the character row or the second row, right? Second row. There's the first row. Append means add to the right. So we add the character to the right, to the output ASCII string. I forgot to add an important word here, an empty string. At first there's no character, so it's empty. Okay, so it's look pretty good now. To the output ASCII string, and we don't need this anymore. But after you finish looping through all of the groups of 8-bit code, you got the final result, right? Like VDA, and now you just need to refer to the variable, to the string variable, and print the value on the screen. So the last step will be print the value of the output ASCII string. Finish. So as you can see from the step by step instruction for human, we convert it into the algorithm for the device. Okay, in using structured English. So I hope that this video is useful and you may learn that first so for a complicated problem you should think like a human first, and then you can adjust it a little bit so that it can fit with the language of solving problem in computing. Yes, so that's all, and bye bye.